Hello and a warm welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here. Today we'll be discussing about the critical minerals. It's a topic related to both environment as well as geography, and we'll be dealing with both the prelims as well as mains aspects. This is the list of things that we are going to read or the topics that we are going to cover. First of all, we'll see what are critical minerals, what is net zero, how they are both connected to each other, what is India's net zero goals? What are India's net zero goals? What is the global situation with critical minerals and India's place in it? What is the challenges that India is facing related to this issue and what is the way forward finally for India? All right, this issue is very, very important as last year also two questions were asked from the same issue or same topic in prelims 23. So can be asked again in prelims 24 also. And over the years in 2022 also questions were asked. So minerals is a very, very important topic and especially the critical minerals. All right, so this is the list of topics as I have already cleared to you. So let's go around this video. Critical minerals. So first of all, we'll have to decode this word critical. What is critical? Criticals means of the greatest importance to the way things might happen. Now let's say we have a goal or an objective to fulfill. So this has to have a process of its own, and towards this process, if something is required the most importantly, then it becomes critical. Without this, the process cannot take place. In the nuclear reactions also, you must have heard about the critical mass. Okay, so even in nuclear reaction, which goes on about itself, cannot take place without this critical mass at least. So critical minerals are elements that are essential for the functioning of the modern societies. Now we are talking about the modern societies, not the society that was going through industrialization previously. Because that time, the production of the steel, the titanium, aluminum, iron especially, okay, that were of the primary importance. Not titanium, sorry. Steel, iron, aluminum, these metals, copper. So they were of the primary importance. Now we are changing, making a shift towards the electronic circuits, towards the magnets, okay, towards the nanotechnology. So for these, recently NVIDIA also released a very good chip, a very small chip with millions and billions of transistors. Okay, so for all these things to happen, for the technology to advance further, we need these minerals of great importance. So these are known as the critical minerals. But they face potential supply risk due to multiple factors. Now, first of all, geological scarcity. This topic, this subtopic of this big topic deals with the geographical aspect. Okay, that where are these critical minerals found right now? So related to this was the question in 2023. If you remember about the cobalt. Okay, the use was given, it was asked that where is it found? Geopolitical issues and other factors. So we'll be dealing with everything in this video. Now, critical minerals are essential to the economic and security interest of nations. So this is basically telling the use to their fundamental role in manufacturing high-tech products. So high technology products, all right, basically dependent upon electricity and electronic projects. Renewable energy technologies such as solar panels, wind turbines, multiple things. Electronic vehicles, so these are the vehicles of future and present also. The defense systems and various other applications. So this is the use case of the critical minerals. Now let us see what makes a mineral critical. First of all, its economic importance. That means it should be economically important for a future goal, a future or present goal. Second thing is there should be a supply risk. It should not be adequately available. That means that only a few countries are producing it. Let's say it has been restricted by a certain area, the technology to extract it is not available, the technology is not accessible, and so on. So that decides the criticality of minerals. All right, so let's see. This can also be a question asked in the prelims next time, that the economic importance of the critical minerals depend upon which things. So these are the four factors on which the economic importance is decided. What is this? Disruption potential. That means how can availability or its unavailability disrupt the market. Substitutability index. That means can it be substituted by some other mineral or not. GVA multiplier score, and cross-cutting index. So please remember all these four things are a factor in deciding the economic importance of that mineral. Furthermore, we see the supply risk. So what creates a supply risk of these minerals? Governance, weight, mineral concentration, end of life recycling rates, import resilience and self sufficiency, and substitutability index. All right, that is SR. So please remember all these 8 things. These can be asked in prelims, that let's say which of the factor does not decide the supply risk of a critical mineral. So these 4 options can be given with one of these, let's say sustainability index instead of the substitutability index. Okay, EI or SR, so on. The significance of this mineral has increased with the global transition toward clean energy. So this is again a very high important topic, critical topic that you must read, and growing reliance on the technologically driven economy. So we have already cleared this, no doubt. The definition and now of what constitutes a critical mineral. So this can vary between countries. So as we see that it is dependent on almost 4 plus 4 factors. So it will again vary between countries, because what can be scarce for one country might not be scarce for another. India has also recently found lithium reserves in Jammu and Kashmir. Okay, so it is also possible that lithium may not be scarce for us, but lithium is not found in other countries, possibly let's say Pakistan, Bangladesh, so it may become critical for them. Now, the risk of supply shortage would ideally capture import dependence, recycling potential, and substitutability of the mineral in question. That can we use something instead of lithium, because not all metals are very, very different. If they are belonging to the same group on the periodic table, all right, or the same column in the periodic table, they might have similar properties. Okay. Now let's talk about the use case. So what is the use of these critical minerals? The cobalt question was asked, and the use was given in the question, fortunately. But lithium, cobalt, nickel, they have similar use. So essential for lithium ion batteries. These are the most important type of batteries produced nowadays, used in electric vehicles, portable electronics, and energy storage solutions. Second thing is rare earth elements, that is REE. These are this is a separate topic, again very important. So you should read about this REE also. So a group of 17 elements, just remember the number also here, used in high strength magnets, electronics, wind turbines, military applications, so on. Please remember the two names, neodymium and dysprosium, for example, are critical for permanent magnets in motors. Okay, there is a topic in physics called magnetic dipole. Okay, so these can become the permanent magnet according to that. Neodymium, please just remember especially. So copper, again important for electrical wiring, renewable energy systems, and so on. Titanium, it is used in aerospace. There was a question on titanium also in 2023, if you remember. We'll be dealing with it at the end of the lecture. So it is used in aerospace for its strength to weight ratio, corrosion resistance, and high temperature performance. It's also used in multiple vehicles. Even the new iPhone is coming with a titanium version. Or it's used in high-end cycles, multiple motorbikes as well. So various different things. Okay, its weight is less and the strength is a lot. Platinum group metals, that are PGM, especially for catalytic converters in vehicles, fuel cells, various electronics. And graphite. Graphite is critical for anodes of lithium ion batteries and its lubricating properties in many industrial applications. It is one of the greatest lubricators, the dry lubricators. Well, it's not a wet one. Because of its shape, it has hexagonal shape, layer by layer shape over one another. Alright. So it slides in the layers. One layer of the graphite slides over the other. So this is why it works as a good lubricant, dry lubricant. Please also remember that in the pencils, the graphite is not used, the lead is used. Although it is written on multiple pencils that it is a graphite pencil, it is actually lead. Okay, that is used. One more thing, environmental impact. So mining and processing of critical minerals can have significant environmental impacts, including habitat destruction, water pollution, and greenhouse gas emissions. So the environmental impact of the critical minerals is what makes it to the UPSC question. Here now you can see multiple children, okay, engaged in the child labor in unsafe conditions. These are of course unsafe condition for mining, and this is what is this happening? Cobalt mining in DRC, Democratic Republic of Congo. So this is what was asked in the UPSC. So just please remember and keep updated with these things. Now we are moving to the next topic, that what is net zero. All right, so net zero means that any emission that are balanced by absorbing an equivalent amount from the atmosphere. Emissions of basically greenhouse gases, carbon dioxide. Carbon dioxide is itself a greenhouse gases, but CO2 is the primary importance here, what we are talking about, carbon capture and carbon release. So in order to meet the 1.5 degree global warming target in the Paris Agreement, this took place in 2015, if you remember. All right, global carbon emission should reach net zero around the mid-century. That means 2050, somewhere around 2050. Okay, India has goal of 2070. In the Paris Agreement, government agreed to keep global warming well below 2 degrees Celsius. Now, what I've seen in multiple exams is that the Celsius is asked in the Fahrenheit. Okay, and to make efforts to keep it to 1.5 degrees Celsius. So I've changed it to Fahrenheit for you. 2 degrees Celsius means 35.6 Fahrenheit, and 1.5 degrees Celsius means 34.7 degree Fahrenheit. This is the formula to convert it. Degree Fahrenheit is equal to 9 upon 5 into Celsius plus 32. All right, so this is a, please remember this formula, and if not, please remember this data at least, because sometimes what happens in the question, it is asked at 35.6 and 34.7. Okay, and you will get confused that I remember the 2 and 1.5 but not this. All right, now let's talk about the India's net zero commitment. So what is the India's net zero goal? So net zero by 2070. Some students are confusing it with 2050. Please don't do that, it is 2070. Reduce emissions intensity of GDP by 45% by 2030. Okay, from the 2005 level relatively, and achieve 50% cumulative electric power installed capacity from non-fossil fuel. That means basically clean energy. 2030 we have two goals: 50% clean energy, if we simplify, and reduction in emission intensity of GDP by 45%. Okay, relative to 2005 levels. So in the union budget, the last year's budget, nearly 4.3 billion USD was allocated to priority capital investment towards energy transition initiative, net zero objectives, and energy security targets. All right. Now we are talking about the gray area. That means, is India rightly blamed for GHG emissions? Okay, so it's not actually. In billion tons. So China is emitting 10 plus billion tons. All right, per capita emission in tons is 8 ton per capita per person. But India has a very low per capita emission despite having the world's most populous country. Okay. And furthermore, overall also India has a very low GHG emission, close to 3 billion tons. So what we are seeing here, that countries like China, USA has 14.9 ton per annum CO2 emissions, 14.9 per person per ton. All right. So this much is every person is emitting in the USA. That is 8 in China. In the European Union and Japan also, they are 4 more times, 3 to 4 times than India. Okay, so per person we are having very less carbon emissions, CO2 emissions, and overall also we are not at a very high number in world. Let's see the India's carbon emission trend. So it's increasing but not at a very high rate. Okay, over the years we see here 2013 to 2023 almost, the last 10 years India has not increased its carbon output by even 1 billion ton. All right, it's still between 2 to 3 billion tons, okay, per annum. Now let's move forward and see that where this carbon is coming from, the carbon emission, where it's coming from. This can be used in your mains, in your prelims, in your interview as well. So power or power generation, electricity generation is accounting to 34% of the CO2 production in India. Okay. And where is this CO2 coming from? Then we see 56.1% CO2 is coming from the fossil fuel. That means coal, lignite gas, and diesel. And India plans to keep it this way until at least 2040, so that our development can take place. We are still heavily reliant on this. Okay, you can read this all when I send you the PDF on the Telegram channel. Now, let's come to the India and critical minerals. What is the situation of India with the critical minerals? So, India has recently identified 30 critical minerals that are deemed essential for the country's self-reliance, and it's making moves to address potential supply chain vulnerabilities. Okay. So, creation of Center of Excellence for Critical Minerals (CECM) is also proposed under the Ministry of Mines. Please remember, and it will also periodically update the list of critical minerals further. So, we have 30 for now. These are the names of the 30 critical minerals. I'll tell you their use case scenario. Please remember the very important states in relation to these critical minerals. So right now they are housed mostly in the Bihar, Gujarat, Jharkhand, Odisha, Tamil Nadu, Uttar Pradesh, Chhattisgarh, and Jammu and Kashmir. I have already told you about the PGE, that means platinum group elements. So these metals have similar physical and chemical properties occurred together in nature. Okay, so these are the PGE. You can remember them or read about them when you are free. Okay, so 30 critical minerals subgroups. So they are highlighted here: scandium, titanium, vanadium, all right, strontium, beryllium, potassium, lithium, and so on. These are highlighted in the PDF. You can read them. Okay, now let's see one more thing, that what is the mineral demand for clean energy technologies by scenario 2020 and 2040. Okay, in the next 20 years, what we are looking at. Okay, so this we see that this yellow thing keeps on growing to maximum here 2040. Okay, so what is this yellow thing? It is electricity networks mostly. So the critical minerals will be used mostly in the advancement of the electricity networks, and there are multiple smaller ones which are solar panel, wind, hydrogen, green hydrogen, all right, the blue ones such as the we see here the EVs and other black battery storages. What we are essentially seeing that in 2014, next 20 years, it will all increase to 6 times the demand for critical minerals. The demand for critical minerals will increase to 6 times by 2040 if we go on the same rate or as our aimed rate. Now let's talk about what is the use of these critical minerals, 30 critical minerals. Okay, so just read about the important ones such as the cobalt, the gallium. From this PDF you can read. Okay, as it's written, I'm not going to dictate this. Hafnium, very important, superalloys, catalyst precursor, nuclear reactors, germanium, optical fibers. So any of these can be asked, that where it is mostly found in which country and what are the issues associated with it. Last time the cobalt was asked, so this time you have 29 more to do. Okay, and question on the titanium also came last year in the 2023 only. So you have basically 28 more to do. So just do these 28, which countries are the major suppliers of these and what is the use case. You can read from here. Okay. Furthermore, let us see what is the global situation with the critical minerals. So India heavily relies on the imports for critical minerals. 100% import reliance on lithium and nickel. So you should read about them, and 93% for copper. In India, copper is mostly found in the Khetri mines in Rajasthan. Okay. Australia, let us see which countries are the major suppliers. So Australia has 55% of the lithium reserves. China has 60% of the rare earth elements. DRC has 75% of the cobalt. This was asked in 2023. These things are often asked in these UPSC exam. All right. Indonesia has 35% of the nickel. So next one can also be asked from this statement only. Please be aware. Chile has 30% of the copper reserves. Okay, so how to remember that Australia has Li, then China has rare earth, Re, then DRC has cobalt. You can skip this, already asked in the prelims. Indonesia IN has Ni, okay, nickel, and Chile has Cu, okay, Cc, INNI, AULI, then CRE, and DRC cobalt. All right, let's talk about what is MSP, okay, mineral security organization or group. So MSP is a collaboration of 14 countries and EU to catalyze public and private investment. Responsible critical mineral supply chain globally. It is led by the USA and it includes India. It has 14 members and it includes India. This is the most important part, but it does not include the countries like Chile, DRC, Indonesia, etc., which are rich in certain critical minerals, raising concern about its effectiveness. Okay, so what it is wanting the MSP? It's a group basically which wants to diverse the supply chain from the influence of China. China has made significant investment in Africa and this region for supply chains or creating new supply chains for the critical minerals. It already has REE, rare earth elements, and it has made significant investment in the Africa as well for such as cobalt, nickel, and other critical minerals. Okay. Now let's see the challenges posed by China, India's largest, biggest enemy right now. So major share of rare earth reserves. So not only does China has major share of rare earth reserves, it also has completely monopolized the processing capacity. Okay, so processing capacity is also very important. First of all, you have to have the reserve. then extraction, then processing, and then only the final output of the thing will be obtained by how to use it. So that will be the technological access. We do not have any of these things, even if we have the supply. Okay, so China has completely monopolized the processing capacity of these minerals. China processes 35% of the world's nickel, 50 to 70% of lithium and cobalt, and nearly 90% of the rare earth elements. Furthermore, Chinese companies have made investment in Australia, Chile, Indonesia, DRC to source these minerals, not endowed with sufficiency. Okay. And China has also monopolized the manufacture of finished products as it supplies 75% of cathode, anodes, battery cells, 95% of permanent magnets. Okay, so everything is being sourced and supplied by China. Okay, because the labor market is very cheap there. So this is one of the, we can say, the positive aspects of China, which it has advanced its economy with. Second thing is setting political scores against countries. So China has used this power to settle political goals against the country, okay, by restricting their exports and so on. Furthermore, now let us see what is the way forward related to this. So what is the India's taken steps towards this issue. So first of all is the establishment of the Khanij Bidesh India Limited, that is Kabil. So please remember this. So in 2019, India established the Kabil, a joint venture including three public sector undertakings, which National Aluminium Company, Hindustan Copper, and Mineral Exploration Company, with a stake ratio of 40-30-30. And Kabil aims to secure critical mineral crucial for India's industrial needs. Achieve this objective, India has forged an agreement with the Argentinian firm to explore and prospect for lithium. Additionally, the government is looking at potential exploration opportunities in Chile and Bolivia. So all of these in South America. Okay, Argentina, Chile, Bolivia. And second thing is India's partnership with Australia. So India and Australia have entered into a strategic partnership aimed at securing the critical mineral supply chain. Both countries have committed a joint investment for US $3 million each in 5 exploration projects located in Australia. Australia has what reserves? Lithium reserves. Okay, and India is 100% dependent for the lithium reserves. So primary objective of this partnership is bolster exploration and extraction efforts, ensuring a stable supply of vital minerals to meet India's goals. Okay, last thing is development of critical mineral policy. So in line with its commitment to sustainable resource management, Indian government is actively engaged in the development of a critical mineral policy. Media reports indicate that this policy will establish a comprehensive framework as well as utilization of critical minerals within India. Okay, that is very, very important for us. Now let's discuss about the PYQ quickly. First question that came in 2023 was ilmenite and rutile. They are rich source of which of the following, or they are ores of which of the following. Okay, answer was titanium, as they are found in the coastal tracts. So I have already talked about this question. Okay, that coastal tracts, we can eliminate the copper, iron both. Copper found here, iron found here. Okay, and aluminum found scarcely here in this region only. Coastal tracts, what we see? Titanium. All right, and this was easily found in the NCRT. This is from the geography NCRT. The toothpaste are made from white titanium. Toothpaste are made white with titanium oxide, TiO2, which comes from minerals called rutile, ilmenite, and anatase. Okay, so this was directly given in NCRT. Here you can read about the detailed solution as well. Ilmenite and rutile TiO2, FeO, chief minerals, and they are found in Kerala, Tamil Nadu, Odisha, Andhra Pradesh, the coastal tracts along these places. Alright, second PYQ we come across is about 3/4 of the world's cobalt. We've already seen where it is found. A metal required for the manufacturing of batteries is produced by Argentina, Botswana, DRC, Kazakhstan. We already know DRC. Okay, so 50% of the world's cobalt reserves are in DRC, where potential for political instability and disruption is high. But why did it came? Because of the mining issues, the environmental impact of the mining issues, and the child labor also. Okay, children, unsafe condition for children. So Congo currently produces more than 70% of world's cobalt, but some artisanal cobalt production poses reputational risk due to human right abuses and use of child labor. This is why it was asked. Okay, applications of cobalt include lithium-ion batteries and magnetic materials, a strong magnet and used in production of permanent magnets. And cobalt is key component in the cathode of lithium-ion batteries. Graphite is also one. Okay, high strength alloys. So it adds the strength to multiple alloys, ceramics and glass. It is used to give the glass a blue color. Okay. So this was the lecture for today. I hope you enjoyed it and liked it. Thank you very much for your presence. I'll be seeing you in the next lecture. This is Yatharth here signing off. I'm wishing you a great day ahead. Keep studying, be happy.